All right. Quick recap of everything that was said in the announcement that was sent yesterday. Tomorrow, so on Wednesday, a quiz should open up and be available. So if you wake up in the morning and it's not available, please do send me an email or ping me here on Discord, and uh, because it's probably me making a mistake and not making it available. That's not my intention, I swear, but we're still learning Blackboard. Um, so that quiz will be about if statements and a little bit about functions. Okay, so we're just doing a little bit of review from ifs and a little bit from functions, asking you to make one, make a definition, make a prototype, and you need to remember some things such as when you're writing a function prototype, remember it's the exact same thing as your function header. The difference is it has a semicolon at the end of it, so don't forget that. And it will have to do with some if statements, and you'll have to write some things, make sure that it's completely optimized so that it's doing as few checks as possible, yada, yada, yada. So, anybody have any questions about ifs slash functions? That's going to be on the quiz. All right. So, again, this is going to be just like the last quiz. So the last quiz, it was open and available all day, but as soon as you open it to take it, you have, I believe we have this one set to 15 minutes, 15 minutes to do it. It's plenty of time. There's not that many questions. Again, this isn't something that's meant to harm your grade in any way, okay? It's just another thing so that when we take the exam, which will be opening up on Friday, when you take the exam, you will have at least seen some questions related to if statements and functions. So it's to get you used to those. So if you're comfortable with the quiz, you'll definitely be comfortable with the exam. And again, on Thursday, so on Thursday, that quiz should be open so that you can see exactly what you got on the quiz, so you can use that as some review material for the exam. And Thursday, what we're going to do, the entire live lecture here is going to be just reviewing for that quiz. I don't think that we'll do any programming on Thursday. I think that we will do just reviewing for the exam and answering any questions that may come up. Uh, can at least one person chime in and say you did see my review sheet that I posted that had some terms and concepts to study?
Yes.
Awesome. Okay. So make sure to check that out before Thursday and ask any questions. I think what we'll end up doing, unless something else comes up, is we'll just open that up and we'll talk about it. We'll, define everything, and we'll be all ready for Friday for that exam. Uh, Heads up, the next week we'll probably have, if not next week, then the week after for sure, we will be assigning a project. We might be doing just one last project, but that's still up in the air. Don't hold me to anything right now. But we might just do one more, and we'll just make it a big one where we'll do a whole bunch of stuff, some really cool stuff, even some things that we haven't done yet, and it'll just be due at the end of the semester. So again, just to look forward. Uh, Nothing definitive yet. Okay,
Yeah, we only have a few more weeks left, don't we? When does the semester end?
so we have, not counting this week, we have 3 more weeks, and then just the day of the finals.
The exam. Okay.
Yeah, and truth be told, we don't have that much left to cover. We have one more thing with functions, which is uh, uh, us doing like multi-returning value functions. So we'll have void functions, single value returning functions, and multi-value returning functions, which I'm going to work on that video this weekend. So look forward to that. I guess I'll make an announcement saying that this video is available. So I'll expect that you have watched that next week, and we'll get into that. Uh, and then I think that's actually the last thing that we need to cover. Could be wrong.
Nice.
So we'll have 2 weeks of probably getting into some slightly more advanced, really cool stuff. But we'll see. And, answering any questions, of course. Okay. So the first thing that I wanted to do a little bit of review when it comes to functions. So I wanted us to write a function. So we're going to write a function that uh, we have a problem where we want to get the hypotenuse. So we have a problem where we want to pass, when we're dealing with a right triangle, let's assume that it's a right triangle, a squared plus b squared equals c squared, right? So if we wanted to get the hypotenuse in a function, can somebody tell me what that prototype might look like? Let's say that we wanted to call it just get hypotenuse. And let's say that we wanted integers for a, b, and c. Well, actually, that doesn't make sense, does it? Let's say that they're doubles.
A squared plus B squared equals C squared.
That that very literally exactly what I'm looking for. No, but let's look at this as the function prototype. So let's call this the prototype here. Ah, my God, my tablet is not wanting to work right now. Sorry. So the prototype, get hypotenuse, double, right? Because we have to put the data type here. And then let's just call this A. And now A would normally not be very descriptive, right? But I think everybody here is comfortable with me calling the sides A, B, and C because that's how math does it, right?
Yeah.
So if I do this, this is my function prototype. Everybody agrees? And where would we put this?
At the
Above
top
the main.
of the function of the program.
Right above what?
The main.
Main. Yep. That's the key. So right above main is where we always put the prototypes. And now where do we put the definition?
Below the main.
Below main. Okay.
Do we need the return type when we are setting up the prototype?
Good point. I forgot that. Okay. Double. Sorry, I'm just squeezing that in there. My tablet, for some reason, isn't letting me go any further left. So that's just where we're getting to. Okay, so don't forget that double there. So this double says this is the data type that we're going to return. So A is a double, B is a double, C will be a double, right? Okay, so given that prototype, how would we write this definition?
In the same manner, but with curly bracket instead of semicolon.
Okay, so you're saying just copy this. So we'll just write double. Get hypot and B. Okay, so just like this, except we have curly braces. Okay, well, let's fill this out. So let's declare our double C equals. How can we do A squared?
The PAL function.
PAL function, that's acceptable. Let's do that. So what do I put in here?
A comma 2.
Comma 2. Okay. And then plus PAL B comma 2, right? So this is A squared plus B squared. So if we wrap this in parentheses, this says add this all together first. Now, A squared plus B squared equals C squared. Well, how do we get just C now?
Square root.
Square root. Okay, how do I do that?
SQRT.
Yeah.
All right.
I can find. You can finally hear me now.
Yep. You know, I had completely forgotten that you weren't able to talk that whole time. I would have made bigger fanfare out of it. I apologize, Jacob. I failed you.
Is it too loud? Just tell me if I'm too loud.
No, you're fine.
Okay.
Okay, so don't forget SQRT, square root, that is a function. Pow, that is a function. Base and exponent are the two arguments that we pass to it. Remember, these are parameters up here, the double A and double B. But when we pass them to a function, they are called arguments. Okay, so let's just add our semicolon there. So now we have C, which is the square root of A squared plus B squared. So that will work. Now what do we have to do in order to get C sent back to whoever calls this function?
Return C.
Love it. Love it. That works. Now, let's just really quick, just so that we can say that we did all the parts of a function, let's actually call this function here with some numbers. How can we do that?
Just type in get hypotenuse, and then parentheses, put in your argument.
So let's say we got a regular 3, 4, 5 triangle, huh? So we can do 3.0, 4.0, and our response back from this, let me just scooch it over just a little bit, and our response back from this should be 5.0, right?
Yep.
Okay. So if you ever see this, remember, if you're calling a function, you have the open and close parentheses. If we wanted to call this and store this somewhere, we would need like a double. Let me erase this really quick. We would need something like a double ants equals, and then this would get the response from the function and store it in ants right here. Now we don't have to store it, but that's usually what you would do with a single value returning function. Does that all make sense?
Yep.
Everybody's good with that?
Quick question.
Yeah.
The definition, is that whole block, your function header and the body all together?
Yes. So, and you already said it right here. This is the function header, and this is the function body. Together, it's the definition. The whole thing makes up the definition.
Got it.
And how I like to think of it is, our prototype is just our function header with a semicolon. That's it. All right. So the next thing that I wanted to do, and I'm going to drop it this file right here in general chat. It's called code trace loop _1 document. So anybody that's watching this video after the fact, just scroll through Discord chat and you'll be able to find the file. Else, just send me an email. Now this is a group work that I will put on the screen right now. So what we want to do is, what we're trying to show is what happens if you have nested loops. So we're going to learn a little bit more about scoping and a little bit more about looping. So everybody feel free to take some time to figure this out. And I'm going to pause. Okay. So we're resuming. And here we go. So what we're going to start with is we're declaring int outer equals 1. So we'll set outer equal to 1. Int inner, so we declared it, but we haven't initialized it yet. Now, while outer is less than or equal to 3. So we do our loop test right away, and we find outer is 1, so is 1 less than or equal to 3? Well, that's true. So we go in, and we set inner equals 2. So inner becomes 2. Now we say, while inner is less than or equal to 6. Well, that's true, because inner is 2. 2 is less than or equal to 6. So we see out set W5. So I'm going to count 5. 1, 2, 3, 4, 5. Yeah, just like that. And we output inner times outer. So 2 times 1, 2. So we'll write that right there. And then we do inner plus plus, so that 2 goes to 3. Inner plus plus, 2 goes to 4. So I'm just going to write that. Just say we go to 4. Now, is everybody following me so far? Okay, good. Good. So this is our modify the LCV stage. Just want to make note of that. So we go back to the top and we say inner, while inner is less than or equal to 6. Well, 4 is less than or equal to 6. So we go back in. And then we see out another set W of 5. So 1, 2, 3, 4, 5. Yep, just like that. And now we have inner times outer. So 1 times 4.
Good question.
Yep.
Why wouldn't the inner equals 2 readjust your inner number to 2?
Because we didn't go back up to this line yet. We're
Oh,
still
okay.
in this loop. So this loop will continue to execute until this is false. Then we will go down, and then we'll go back up and test the loop test again. And if that still is true, then we'll come back down and set inner equal to 2.
Okay.
Does that make sense?
Yep.
Okay. Once we're done with this whole example, if that doesn't make complete and total sense to you, then let's talk. Okay. So, like I said, that's a set W5. So we do inner times outer. So 1 times 4. So we end up with 4 here. And then we do inner plus plus, inner plus plus. So we end up with 6 for inner. Now when we go back up to the top here, we have 6 less than or equal to 6. Well, that's still true. So we go back down, set W of 5. 1, 2, 3, 4, 5. Yep, just like that. And then we do inner times outer again. So this ends up becoming 6. Because 6 times 1. And then inner plus plus, inner plus plus. So we end up doing 6 plus 2. So that becomes 8. Now when we're back up here, we say, is 8 less than or equal to 6? I hope everybody knows that that's false. So we exit and we go down to the bottom here. We exit the loop. Okay, and then we see out an end line. So when we see out the end line, we know that just write my lines again. We are here. We are on the new line. So let me clear this out. So we see out that end line. So we're on the next line. And we do outer plus plus. So outer becomes 2. Now we go back to the top here. And we're doing this loop test where we say, is outer less than or equal to 3? That's true. So we go in and we set inner equal to 2. Now, Jacob, that makes sense now?
Yep, everything makes sense now.
Okay,
Yep.
good. And then we say, while inner is less than or equal to 6. Well, 2 is less than or equal to 6. It feels like we've already done this before, right? So we come back in here and we say, we see out set W of 5. So 1, 2, 3, 4, 5, right there. And we do inner times outer. Well, inner is 2, outer is 2, so we see out 4. And then we do inner plus plus, inner plus plus, so this ends up turning into a 4. Okay, go back to the top of the while loop here, and we say, is inner, or 4, less than or equal to 6? That's true. So we go in and we see out a set W of 5. 1, 2, 3, 4, 5. Yep, right there. And we do inner times outer. So that's 2 times 4. So we end up with 8 this time around. And then we do inner plus plus, inner plus plus. So this turns into a 6. We go back to the top and we say, is 6 less than or equal to 6? Still true. So we go in and we see out our set W of 5. 1, 2, 3, 4, 5 here. And then we do inner times outer. So 2 times 6 is 12. So we write our 12 like that. And then we do our inner plus plus, inner plus plus. So 6 turns into 8. And now we go back to the top and we ask, is 8 less than or equal to 6? Now that's not true. So we exit out of the loop and we start executing here at this line of code. So we see out another end line. So let me give myself another line here. Like so. And then we do outer plus plus. So outer plus plus, this turns into a 3. Now we're going back to the top here. We ask, is 3 less than or equal to 3? That's still true. So we set inner equal to 2. So inner becomes 2. Now, while 2 is less than or equal to 6, that's true. See out set W of 5. So we count our 5 again. And then I'm going to make a little mark there for me. And we do inner times outer. So 3 times 2 is 6. And then we do inner plus plus, inner plus plus. So we end up with 4 inside the inner variable. And then when we get back to the top, we ask, is 4 less than or equal to 6? Still true. So we go in and set W of 5. So right there, make a little mark for myself. And then we do inner times outer. So that becomes 3 times 4, which is 12. So we write our 12 like so. And then we do inner plus plus, inner plus plus. 4 becomes a 6. Go back to the top. Is 6 less than or equal to 6? That's true. So we go in and we do our next set W of 5. And then we do inner times outer, 3 times 6 this time. And 3 times 6 is 18. So we write that to the screen. And then we do inner plus plus, inner plus plus. So 6 turns to 8. Go back to the top of the while loop and we say, is 8 less than or equal to 6? That's false. So we exit the loop and we see out our new line. So we would have a new line down here. like that. And then we do outer plus plus. So 3 turns to 4. And then we go back to the top of the loop and we say, is outer less than or equal to 3? So is 4 less than or equal to 3? That's false. So we exit this whole loop and we end up going here and we're done. So, did anybody get this exact answer?
Nope.
Was it close?
Kinda. I just didn't stay in the second while, so I kept going out. So I got to 818 and missed all the other ones in between.
Ah, okay, okay. You see how I did it though, right?
Yeah, yeah,
Okay.
definitely.
And it made
So you have to
sense.
stay in this within the second while loop until that parameter's reached. Then you go back out.
Yep. When you're inside of a loop, you stay inside the loop until you're done. Okay. Now, are there any questions with this looping here? Now, so the one thing that I wanted to do with this as well, just to throw it on there, we hadn't talked a lot about, at least not together here, we hadn't talked a lot about doing a for loop. But it was mentioned in the video, and hopefully everybody got a good feel for how to write a for loop. So actually, before we do this, let's just set this to the side right now, and let's just write out, how would we write a for loop? Does anybody know?
Because it requires 3 parameters, and the modify LCV is the last one.
Oh, okay.
For int I, comma, or you have to set it to 0?
Yes, you have to set it to whatever you want to start at.
Gotcha.
So for int I equals 1, or 0.
0, comma, or semicolon I plus plus.
Close. I less than 5, let's just say. So this is our loop test goes in the middle. And then last we can have an I plus plus. So this first part, this is us initializing the LCV. So we're saying this is I is our loop control variable. We're declaring it and we're setting it all in one line here. Semicolon. Then next is our loop test. So we will continue to loop as long as this is true. As long as I is less than 5. And then we do, lastly, is our modify LCV. So it's in the exact order that I've been saying repeatedly, where we declare and initialize the LCV, then we do the loop test, and then we modify the LCV. It's in that exact order, okay? So now, if I put some curly braces here, let's just see out I. Actually, I want to do a new line here. And that is an I right there. So what is going to get written to the screen when we run this loop?
1 new line, 2 new line, 3 new line, 4 new line, 5 new line. Actually, it'll stop at 4, won't it?
Okay, okay. Well, let me just keep that written down, and then let's go through it, and let's talk through it. I know this is the first time we've seen this for loop together, so what this is going to do is it's going to initialize the LCV to 0, and then it's going to do the loop test. So I is 0. Is 0 less than 5? That's true. So we enter into the loop here, and then we see out I. Well, I is 0, so it outputs 0. Now we're at the bottom of the loop. It's going to come back up, and it's going to execute the modify LCV. So I becomes 1. And then we do the loop test again. I know it's weird. It's going from right to left now, and it skipped it the first time, but stick with me here for a second. So I is 1 now. So 1 is less than 5. That's true. And since that's true, we're going to enter into the loop and we're going to execute again. So we write a 1. Now we go back to now we modify the LCV. So 1 becomes 2. 2 less than 5, that's true. So we output 2. 2 becomes 3. Is 3 less than 5? That's true. So we output 3. 3 becomes 4. Is 4 less than 5? That's true. Now 4 becomes 5. Now is 5 less than 5? That's false. So we're done. We exit the loop. So you were very close. Just off by 1 number. And does that make sense? Why?
Yeah, and arrays start at 0 in C# too, right?
Yes, yeah. They do in any good programming language. Okay, so with this in mind, with our little bit of going over for loops as a little bit of review, because I know that everybody watched my fantastic video on for loops and looping in general, let's take this and let's translate these nested loops into 2 for loops. Okay? So first of all, this is our initializing the app. I just wrote right over it, didn't I? This is our initializing the LCV, right? Everybody agrees? For our outer loop, at least. Okay, so if that is the case, I can write, instead of int I, I'm going to say int outer equals 1. So notice before I wrote int I equals 0. Well, this one starts at 1, and I'm not going to change that. So we'll just keep that the same. Now, what is our loop test here for this outer loop?
Outer less than or equal to 3.
I agree. Now, what is our modify LCV for this outer loop?
Outer plus plus.
Outer plus plus, just right there, right? Love it. So then we close that off. We write our curly braces, which I can never do appropriately. I just kind of scribble. And then we get in here and we realize, oh, this is our initializing the LCV for our inner loop, right? So let's start writing our inner loop here. For. And now how would we initialize our LCV here?
Int inner equals 2.
I agree.
Why do we need the type when we initialize it there? Isn't it already set when we declare the variable?
Well, in this example, we haven't declared the variable.
Oh, I gotcha. I see what you're saying.
Completely separate. Now, if you're asking, could we have said, just like we did here, and put int inner like that, and then could we do this? Yes, we could. Yes, we could. I don't want us to do that because it's kind of a bad practice to get into.
Okay.
This just keeps us in a very narrow scope for our loop variables, right? Because once we're outside
Gotcha.
the loop, those variables are destroyed now, which is good for us. Okay. That was a good question, though. Thank you for that. And now, what is our loop test here for this inner loop?
Less than 7?
Less than 7. Okay, I like that. That's technically correct. But can you translate it to exactly what's in this one?
Less than or equal to 6.
Thank you. Yep. I like it though. I hope everybody sees why less than 7 is the same as less than or equal to 6, right? Okay, good, good. Now, what is our modify LCV here?
Inner plus 2.
Inner plus 2. Like that?
Yes.
No. That was a trick. You fell for it. You would have to do inner equals inner plus 2, right? To set it. Or you can do inner plus equals 2. Sorry, that's getting messy. But you remember inner plus equals 2 is shorthand for inner equals inner plus 2. Because if you just write inner plus 2, inner is not getting changed there. You're just writing a mathematical expression that doesn't set the value of inner. You see that, Alex?
Yeah, I see that.
Okay, good. Good, good, good. So now, what is our loop body for our inner loop?
See out, set W5, and then it would be inner times outer.
Did I write otter? Now, do I write inner plus plus? Nope. Right? Because I already handled the modify LCV. It's right here.
So in a sense, a for loop is kind of more concise.
It is more concise. Yes. It's a lot more concise, and it doesn't let you forget to do your modify LCV because
Right.
it's got to be there. If it's not there, it won't compile. Okay, now right out here, we just got to do one more C out really quick. We're almost there. And then I want to talk a little bit about exactly what you were trying to say there, Jacob, which is about the benefits of the for loop. So this is the exact same code as this. Because we're lazy programmers, we like this better when it comes to counting. When we have a count control loop, generally speaking, a for loop is the best structure to use. And I hope that you could see why, because we declare a number. We have our loop test right here. And we have our modify LCV that makes sure that we are, well, it's not checking that we're for sure getting closer and closer to exiting the loop, but at least it makes it so that we have to include all 3 pieces of our loop. Otherwise, it won't compile. And going back to the difference between if we declared int inner up here, and inner was just available throughout the whole execution here, well, this is a lot more convenient to have it here, because then when we're outside, after we get outside of the for loop and let's just say we're right here, we're executing this C outing the end line, inner doesn't exist. That variable is not defined out here. So it's convenient because we're not cluttered with so many variables that we don't care about outside of here. We only care about inner in here. Does that all make sense so far? And we got to see how to translate a count control loop from a while to a for loop. Okay. All right. Well, that's actually all that I really wanted to cover today. So let me pause.